Hello class, we're about to start section 5.1, inverse functions. Functions and inverse functions do and undo each other. You already know a lot of functions that are inverses of one another. Now listen, I had to take the liberty of having these charts filled out because like I said in previous videos, they jump a little bit. So here we have x plus 3, the inverse is x minus 3. Now, when we do the notation, we know that typically we write our notation as y is equal to some value. But we also know that f of x, h of x, g of x, and so on of x is actually our y value. So we take the function x plus 3. That is the same as f of x is equal to x plus 3. So this goes with this here. Now we go here to the inverse function. Now if you notice, we have our x minus 3, which we have here. But to indicate the inverse function, we take this f, and it looks like a -1 power, but that means inverse of x. So f inverse of x, this is pronounced as f inverse of x. And that's equal to x minus 3. Whatever the inverse is, whatever your y value is represented as, you always put the -1 value up here to indicate an inverse. Now we go here to our 5x. Now 5 times x, we know the inverse of 5 times x is x over 5. Now we know with this initial function of 5x, that'll be gx is equal to 5x. But now we want to write the inverse. So it'll be g to the inverse, which looks like a -1 power of x is equal to x over 5. Now we go to the next value. We have the square root of x. We know the opposite of a radical is an exponent. The square root of x inverse is x to the second power. So we have h of x is equal to the square root of x. And then we will have h inverse of x is equal to x squared. Now we come here where we have x cubed. The inverse of x to the third power is the cube root of x. So we know k of x is equal to x cubed, and the inverse of k of x is equal to the cube root of x. Now it says notation. If the first function is f of x, then the inverse function is called f inverse of x. Notice that the -1 is not an exponent here. It is simply notation to distinguish an inverse function. We use inverse functions all the time when we solve equations, as we try to get the variable by itself. Now, we are applying the inverse of the operation that has been done to the variable. So if we look here, we had 3x minus 8 is equal to 23. Let's say we're going to solve for x. We will add 8 on both sides. So we will have 3x is equal to 31. Now if you notice, we applied the inverse operation here. We had minus 8, so we added 8. So now we're left with 3x is equal to 31. And we know the inverse of this 3 times x is to divide by 3. On both sides. So x is equal to 31 over 3, which is the inverse. So this is using inverse operations, which you have done since you have been using algebra. So now we scroll to the next page. It says here, we can visualize the relationship between a function and its inverse with a diagram. Now, if you look here at this diagram, first of all, we have our function. And down here, we have our inverse function. So first thing we would do is this. Substitute in 2 for x. We know 2 to the third power will give us 8. So, now, that is our function. Now we want to do the inverse function. So we could do this by using arrowheads, and I'm going to change the color a little bit. So in using the function of 2 to the third power, that gave us 8. Now if we want to do the inverse, which would be the cube root of x, we know the cube root of 8 will give us 2. So we will go back and using our inverse, that's what gives us 2. So now we go here to 3. Now we have 3 to the third power, which we know is 27. And we know that is our function. So we will use our function, and that gave us 27. Now if we did the inverse of this, we would take the cube root of x, which we know is 27. Which is 3. So we would go back here. Now you're starting to see the relationship. We have the function. Then when we do the inverse, we go back to what we started with. So this, of course, let's label this. This is our domain. And this here is our range. Now we go here to 4. 4 to the third power, we know is 64. And we know we use our function, so we'll go here from 4 to 64. But now we use our inverse function, and that would take us back to 4. Now we go to 5. 5 to the third power, we know is 125. So we know using our function, that gave us 125. Now to do our inverse function, we would end up back at 5. So this is basically showing you the relationship between the regular function and its inverse. They should get each other. Now we scroll down. Now if you notice here, we have another chart here. It says we can also see the relationship in a table. We have f of x is equal to x cubed, and we can substitute in some values here, 2, 3, 4, 5. And we know 2 to the third power is 8, 3 to the third is 27, 4 to the third is 64, and 5 to the third is 125, which is what we had up here in the diagram. We just rewrote it in a table this time. Now we do the inverse function. If we put in a for x, if we put this in the radical, the cube root of 8, we know is 2. Cube root of 27 is 3, and so on. If you notice, the x and y values just switch places. This y became x, and this x became y with the inverse. Now, it says note. Now, in your course pack, you more than likely have note when comparing a function with its inverse function. And we could put this, the input and output rows are switched. And we could put swapped. Switched or swapped. That is the x and y trade places, which we saw up here in the table. Now, we need to scroll down to our next page. We come down here to example 1, which says the function g of x has values as shown in the table. Find the following. Now, if you look here, we have g of 4. So since this is g of 4, we know that we will go and take a look at the x value where x is 4, because we know this represents x. So this is g of 4. So then when we have x is 4, then y or g of x would be 2. So this is 2. Now we go here to g of -1. This is the inverse. So that means that we need to find where y is 4. So we have y or g of x. We know that this, as you see, this jump, we know that this g of x represents y. So the inverse of g is our y value. So we will go where our y value is 4, and here our x value is 3. So our answer would be 3. Remember, they switch places. Now we go to the inverse of 5. So that means we go to our g of x value, that's 5, and we will write down our x value, which is 2. Now we just have g of 5. So we will go where our x value is 5 and write down our g of x value, which is 0. And that's it. Now, we scroll down here to example 2. It says the function f of x is graphed below. Find the following. Now we want to find the function of 1. Or f of 1. So what we would do is we would go to the x-axis where x is 1. And then we will find out what our y is. If we go up, we notice that our y is here. So we need to go up 1, 2. So f of 1 is 2. As you see here, this jump, so we know that this 2 goes up here. So f of 1 is equal to 2. Now we have the inverse of 1, the inverse of f of 1. So we will go where y is 1, which is here. And if you notice, our x value is 0. So for this answer here, let me see if I write it to the side. So b should be 0. So this jumps as well. So let's see if I write it. Oh, well, it still jumps. So we know 0 goes with f, the inverse of f of 1. So now we go to c, which is f of 5. So that means we go on the x-axis to 5, and then we go up until we hit our y value. Now if you notice here, our y value would be 4. So I'm going to write 4 here. So then we know that this 4 goes with c. Now we have the inverse of f of 5. So we would need to go where y is 5, and then we would go over to our x value. Now our x value here, we notice, is 8. So this answer for D here is 8. And sorry for the shifting, but you know this 8 goes with D, 4 goes with C, 0 goes with B, and 2 goes with A. Now we scroll down here. It says note. We can tell that f of x is a function. Every input corresponds to only one output. Now the graph of f of x passes the vertical line test. Now remember, with the vertical line test, that means that the vertical line only touches the graph once. So again, the vertical line only touches the graph once. Now, furthermore, we could tell that f of x has an inverse because it is 1 to 1. Every output corresponds to only one input. The graph of f of x passes the horizontal line test. Which basically means the same thing as I told you before, except for the horizontal line only touched the graph once. Now we scroll down. It says here, graphing inverse functions. For the graph, make a table of values of f of x and another for the inverse of f of x. Use the tables to graph the functions f inverse of x on the same axes. Now if you notice here, I have already filled this out and even graphed it. That's because everything was jumping. So we're going to talk about this. So first of all, I had x be 0, 1, 5, 8, and 12. And then I also figured out those points here. And these points were already plotted for you. Now we have to do their inverse. So the inverse is, your f of x will become 1, and your x will become the f inverse of x. So if you notice, they all switched. Okay, so now we plotted those points here. Now if you notice there's a line drawn straight through the middle here. This is called the identity line. Basically, this identity line basically states this. If you were to fold this across the identity line, then you would notice that they will reflect each other. They would be exactly on top of each other. So what we have here is this here. It says if the point AB is on the graph of f of x, then the point BA, B comma A, will be on the graph of the inverse of f of x. The result is that the graph of f of x and f inverse x are reflections of one another across the identity line.